Okay, guys. Hi. Just today's lesson. So let's have a look at yesterday's, Monday's at this stage. I hope you all had a nice St. Patrick's Day, by the way. Different, I'm sure. Um, we had a look at surface areas of nets, and we looked at nets as a concept, what a net is. Okay, so look back at that if you haven't done so already. Please look at that before you go ahead and do today's work. I set the homework there, page 275, question 2, 3, 4, and 6. If you need any help with question 2, 3, or 4, just get on to me, email me, or put it in your section on OneNote there, and I'll see it and I'll get back to you. Because I have answered question 6. Okay, I did answer question 6 down below today, here Wednesday. So that's question 6 there, and the solution to it. Yeah, so part 1, part 2. Also, there, video embedded, okay, from YouTube. I created a YouTube channel so I can embed these videos because they'll be much better this way than the file way I did on Monday. Okay, so always improving. Yeah, so let's have a look. You can have a look at that question 6 there. I did have a video for that, but it didn't work out, and I'm not going to do it again. But if you do want me to explain this further, please, like I said, just get on to me through OneNote or email me. Okay, prisms. That's what I want to look at today. So a prism, what is it? It's a three-dimensional 3D solid, and it has parallel congruent bases that are both polygons. So, okay, big words here. Congruent means identical. We had that before. Polygons, two-dimensional shape with at least 3 sides, has to have 3 sides minimum. Okay, now they call this the base. Okay, I call that the front face. Okay, and the other end of it is exactly the same. It's congruent. That's what congruent means. Okay, there's a picture there of the Toblerone bar. Just think of the box that comes in. You know, that is a triangular prism. Okay, now a right prism over here, that's one in which the basis is directly above the other, just like what we have there, the triangular prism. Okay, that's a right prism. Its side faces are therefore rectangles. Okay, and another example, I suppose, here is question 1. Okay, in your books. Now, what page is that? Let me just have a look. In your books, this is page 277. Page 277. Okay. You can see it has the front face here. Okay, that's the front face there. Oh, there, let's do that better. So there's the front face. Okay, and then it has all these rectangular sides. Okay, rectangular side here, 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 up here, back there, and underneath as well. They're all rectangular. Okay, so this is a right prism. Okay, now let's get rid of all that mess. So yeah, I've already started this one, and what are we to do here? We have to get the volume of this. Okay, this right prism. The volume of a right prism. Let's break it down. You can see in the green box up here actually, the green box here. Volume of a prism is the area of the base multiplied by the length. Okay, I have a little bit of a different interpretation. It's the same thing. It's just different language, different words. Volume of a prism. 2 steps. Get the area of the front face. Okay, just get the area of it. Then multiply that by the depth of the prism. So looking at this, the front face of this consists of 2 rectangles. Okay, that's the way I broke it up anyway. We could have broke it this way too, but same thing, 2 rectangles either way. Now, I've already gone ahead and got the area of rectangle number 1. Now I have to get the area of rectangle number 2. Area of 2, I just labeled them 1 and 2. So that's going to be 25 multiplied by 20. Okay, so I'm looking at these figures here and here. Okay, now you need to multiply that out. You might need to grab a calculator. That's 500 centimeters squared. Now we need the total area of that front face. So of course, when you're getting total, you need to add total area of the front face. Okay, so we add these up, and we get 1,625 centimeters squared for area. Now, this has depth. This shape has depth. It's a right prism. So we need to multiply it by, as I said over here, the depth of the prism, which is, we can see it here, 30. Okay, so we multiply our area here. So total area, the volume is equal to total area of front face multiplied by depth. Now you can see, you don't have to write this out yourselves, okay? You can see now in maths why we like to have shorthand ways of writing out them, because otherwise you just write out big sentences like that. So anyway, the total depth is this, and we're going to multiply that by the depth, which was 30. So I'll grab my calculator here. 1625 multiplied by 30, and that gives me an answer of 48,750 centimeters cubed, because it's volume. Okay, now I don't want to, I'm just conscious about making big video files here, so I'll cut this one here, and for getting this up there, I'll do a separate video for that.